Welcome back, class. Today we're going to learn about the product of complex numbers. The product of complex numbers, you simply apply the distributive property as if you were to multiply two binomial, given that it is in the form a plus bi. Okay, so you apply the distributive property. There's one thing that is essential that I need you to remember. Whenever you see I squared, you replace I squared by -1. If I squared is replaced by -1, then you're in business and you can find the right answer. Without further ado, let us look at the following. The complex number 2 plus 5i times the complex number -1 plus 3i. We apply the distributive property. You know it is the 2, the first term from the first one, times everything on the second one, and the second term from the first one times everything from the second one. And from there, you should know anything outside the parentheses, multiply everything inside. As a result, you have the following. The 2 multiplies the -1 and the 2 multiplies the 3i. Similarly, the 5 multiplies the -1 and the 5i multiplies the 3i. Yes. And it was the 5i times the -1, of course. And now, ladies and gentlemen, as a result, we have the following. -2 plus 6i minus 5i plus 15i squared. Remember, the idea is to take the I squared, replace it by -1. As a result, we obtain -2i plus -2 plus I plus 15 times -1. Combine like term, the constant is -15 and -2, we obtain -17 plus I. Let us look at another one. So, 5 minus I, the expression, times the expression 3 plus 4i. We apply the distributive property as we had before. And, ladies and gentlemen, we have the following. And now we have 15 plus 20i minus 3i minus 4i squared. As a result, we obtain 15 plus 17i minus 4 times -1. Remember, I see I squared, I replace it by -1. Hence, I end up with 19 plus 17i. That's what we end up with. That's the complex number obtained by multiplying the complex numbers 5 minus I and 3 plus 4i. So at this point, we're going to look at the quadratic formula. The quadratic formula, ladies and gentlemen, is going to help you solve practically any quadratic equation. It will provide you the answer. And now, try to solve this below. Recall that we have been solving by factoring. And in this, if you try to factor it, you will not find two linear factors that will give you 2x squared plus 5x minus 1. Since we cannot find the two linear factors, we have to refer back to the general form of quadratic equation or expression. Hence, the general form as we know it, it is ax squared plus bx plus c equals 0. What we try to do in this case, we're going to identify the a, the b, and the c. Well, ladies and gentlemen, given that the two equations are aligned, we should notice that the a is 2, the b is 5, and the c is -1. As a result, ladies and gentlemen, we have the information we need to use the quadratic formula. What is the quadratic formula, you might ask? Now, the quadratic formula is x equals negative b plus or minus the square root of the expression b squared minus 4ac, everything over 2a. Again, make sure you understand that the quadratic formula is x equals negative b plus or minus the square root of the expression b squared minus 4ac all over 2a. All right? And ladies and gentlemen, we're going to just replace the letters by the numbers, which we have above a equals 2, b equals 5, and c equals negative 1. I strongly suggest when you're substituting the numbers, make sure you put them in parentheses so you know what you're substituting is inside the parentheses, so that you do not mix up the sign or take away a sign that's already there. Any sign that comes with the formula must remain there. As a result, ladies and gentlemen, we have negative 5 plus or minus, notice those things stays, the square root of the expression 5 squared minus 4 times 2 times negative 1. Notice that the minus 4 remains there because it's part of the formula. Notice the negative before the 5 remains there because it's part of the formula. Alright? And now from there, we simply do the arithmetic to simplify. And we get negative 5 plus or minus the square root of 25 plus 8 and over 4. And we simplify further and we obtain negative 5 plus, it should be plus or minus square root of 33 over 4. But we can write this in two different answers. Since the quadratic has two answers, we also have the negative 5 minus the square root of 33 over 4. Alright? These are your two answers, ladies and gentlemen. It can be written in ones, as in negative 5 plus or minus the square root of 33 over 4, or we can write it separately. You will see both forms. Let us look at another. Notice that they ask you to find the solution of the following. Since the letter is m, we will use the quadratic formula where m equals negative b plus or minus the square root of the expression b squared minus 4ac all over 2a. So let us identify a, b, and c. This is a, b, and c. And we now substitute. Once we substitute, ladies and gentlemen, we're going to have negative times the negative 1. Notice that even though 1 is negative, I don't take away the negative that comes with the formula. Alright? So I have negative times negative 1 plus or minus the square root of the expression negative 1 squared minus 4 times 3 times 6 all over 2 times 3. Alright, now let's do the arithmetic. What we got, ladies and gentlemen, we get a positive 1 plus or minus the square root of 1 minus 72 over 6. And if we have this, ladies and gentlemen, we end up with 1 plus or minus the square root of negative 71 over 6. Pay attention closely, see what happens. Now we have plus or minus 1 plus or minus I square root of 71 over 6. Notice it was negative. Now the negative, we have I on the outside and square root of 71, which is positive. I is the square root of negative 1, ladies and gentlemen. Hence, this is your answer right there. You can see it in this form, such that it is 1 over 6 plus the square root of 71 over 6i. Now, that is the standard form of the complex numbers. That's why I write it like that. So you have your real part and you have your imaginary part. That is it, ladies and gentlemen. If you have any question, please feel free to ask and comment. Good day.